Okay, year 11, I'm going to move on to the expected mean, or what we call, um, the expected mean, or it's also the average, but we're going to talk about it as the expected mean. Before we do that, I just want to go over, you need to be making sure you're making some notes. So I've just listed some notes from the beginning, the first two exercises that you need to know. So, and I've listed them here. So you can see I've got a definition of continuous data, discrete data, what mutually exclusive means, what a discrete random variable is, and what a discrete probability distribution is. And realize that you can represent that as a table, a graph, a function, and you need to know all the properties of that, knowing that they must add up to one, and if they're a uniform distribution and so on. Now, I've written some notes here because even though we don't discuss this now, we're going to discuss it later in year 12. So we may as well get some of this information out now. We're going to be talking about population, and we're going to talk about sample. Now, for the work we're doing now, we're going to be using the population, which is everything in a discrete distribution. But later on, we're going to be talking about samples. Now, when we talk about population, it's usually associated with theoretical probability, and we're going to be using Greek letters. So when you did statistics, you would have used the mean, and you would have looked at it with an X with a dash. Now, we're going to be talking about this with population, and we're now going to be talking about the mean, and we're going to be using the population mean, and we use the Greek letter. What is that Greek letter? That is U. I'm not sure. Hold on. We'll find out. I've forgotten what it is. Now, when we talk about standard deviation in statistics, and we're talking about sample, we use the letter S. When we talk about standard deviation and we're talking about the population, we use sigma, lowercase sigma. And when we talk about the sum, and you will have seen this before, we use the capital sigma, which means sum, add up. And we might say, oh, that's the frequency. Now, the mean or expected value. Because we're doing probability distribution tables, I'm going to do an example in a minute, we need to calculate the mean or expected value, what you expect to get. So, for example, when you roll a die, and we're going to do this in a minute, what do you expect to get? What would be the average? Which is, the mean. Now, to calculate this, the mean, we say, that's the expected value, capital X, the expected value of the whole probability distribution. And mu, that's it, mu. We can use that, and that means the mean, and it's for the population. If I was using it for a sample, I'd have X with a bar. But the way we calculate it is it's sigma X, P of X. Well, what does that mean? Well, sigma, so expected value, what you expect to get, and what does this mean? Well, that means sum, and that means that's just your score in your probability distribution table, and that is a probability. So what does that mean? It means what you're going to do is you're going to sum it all, the scores times the probability. Now, if you think about it, that's what you do to calculate the mean. So let's do rolling a die. So let's set up XP of X. What do you expect to get when you roll a die? What do you expect when rolling a die? Well, what are my scores? Well, it's a discrete probability, a discrete distribution table, probability distribution. So X, I can get a 1, a 2, a 3, a 4, a 5, or a 6. What's the probability of each of those? Well, it's a uniform probability, and they're all 1 on 6. So, well, what do I expect from this distribution? Well, I take the scores, 1 times the probability, 1 on 6, and I add each of them up, 2 times 1 on 6. 3 times 1 on 6. 4 times 1 on 6 plus 5 times 1 on 6. I'm just going to turn my thing down. Plus 6 times 1 on 6. So if I add them all up, that becomes 21 on 6, which is 3 and 3 on 6, or 3.5. So when you roll a die, you expect to get 3.5. Now, you can do that manually, but you know you have a function on your calculator that allows you to do that. So let's set this up. So let's put it on stat. We're going to do one variable statistics. But what you want a frequency column. So go Shift, Set Up. You can't see it there. Go down to number 3, turn your frequency on. Now you've got a frequency column. So you just put 1, 2, 3, 4, 5, 6. And over in this column, you just go 1 divided by 6. It'll write it as a decimal, but don't worry. 1 divided by 6. 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 Now it's in there. That's all clear. Shift, Stat. We want the variable data. Now you can see here we've got some different letters. Remember, number 1, N, tells you the number of scores. X bar is the mean. Now, even though it is, when we talk about those letters, we mean that's for a sample population. In this case, we put all the data in. So we should just get the sigma, or the expected value. Mu, or expected value. And here, this is number 3 is the population standard deviation, and number 4 is the sample standard deviation. Note, Greek letter for population, standard English alphabet for sample. So let's hit number 2, and we should get 3.5. If I can hit equals. And there we go. So your calculator will do it as well. So when you go and do these questions down here, by the way, there is the expected value, and I should have written, and you need to write, the expected value. Oh, we already have. Notice here, Greek letter. And here you can see it is the mean or expected value of a population, we use X bar for mean of a sample and mu for the population. All right. So we go down here, they go through all that, and there is the formula. Sum it all up. They give a nice little proof of that. And then we just go through and do these questions. Now you can see how they're teaching you how to do it on stat, but you've got to have a frequency column. So when you go through and do these, do a couple manually and do a couple using your calculator. Don't do too many manually, they'll take you too long. So let's have a look at the first one. Find the mean or expected value. Oops, so here we go. Here's question 1A. The expected value, so it's just the score, so 0 times the probability, a quarter, plus 1 times a half, plus 1 times a quarter, which is 1, because we'll get a half. Hold on, is it 1? Oh, it's 2, you peanut. 2 times a quarter. So I get a half plus a half, which is 1. You can do the next one, but I'd probably use your calculator for it. Let's have a go at C using just by hand. So the expected value equals 1 times an eighth plus 2 times a 16th plus 3 times a quarter plus 4 times 3/8 plus 5 times 3/16. And for this to be a discrete probability distribution, remember, all of these probabilities must add up to 1. Anyway, you put them in your... You do this next bit on your calculator, but you'd list all that so that you know what, or you have an idea of what you're doing. And I'm going to have to do it on my calculator now. So I'm going to have to get out a stat and go to comp so I can write it. So 1 times 1 on 8 plus 2 times 1 on 16 plus 3 times 1 on 4 plus 4 times 3 on 8 plus 5 times 3 on 16. And I get 50, and I want that 3.4375, I think. Was that it? Righto. And I'm just going to go to the solutions to make sure we've got them right. What are we up to? 1203. Come on. 1203. And they give me 3 and 7, 6. I'm just going to, 3 and 7 on 16. So that's all you do for these. And there are not very many. Just going through, if you go back to the beginning, go through and you're calculating the mean. For question 3, 4, they're all pretty standard. draw up a probability. A uniform discrete has 1, 2, 3, 4 draw. So I'm going to do 3 and 6. So let's have a look at 3. Find the expected value of each of these. The number of heads when tossing 2 coins. So here we go. So here's 3A. When I toss 2 coins, I can get 0 heads, 1 head, or 2 heads. Well, what's the probability of getting 0 heads? Well, when I toss 2 coins, I get a head and a head, you get a head and a tail, you get a tail and a head, or a tail and a tail. So, chance of getting no heads, 1 on 4. 1 head, 2 on 4. 2 heads, 1 on 4. All those have got to add up to 1. So my expected value is 0 times 1 on 4 plus 1 times 2 on 4 plus 2 times 1 on 4. Oh, 0 plus 2 quarters plus 2 quarters are 1. So 3A, the answer should be 1, and it is. So you can do that with all those. And when you have replacement and non-replacement, so let's have a look at 3E. What have we got? The number of red counters. The number of red counters when 2 counters are selected random from a bag containing 7 red and 12 white. So I can get a red and a red, a red, and what am I want the number of red counters, a red and a white. I can get a white and a red, or a white and a white. So what's the probability of each of these? So this is going to be a bit harder because I have to work out the probability of what can happen. So to get a red and a red, and first of all, we'll do with replacement. So 0, well, what's the probability of that? Well, that means I get a white and a white. And what's the chance of getting a white and a white? Well, there are 19 counters. So 12 on 19. Oh, hold on. I'm going to write this down here so you can see the probability. So the chance of this happening is 12 on 19 times 12 on 19. The chances of this happening is 12 on 19 times 7 on 19. And this is 7 on 19 times 12 on 19. And this is 7 on 19 times 7 on 19. Because each of those probabilities is multiplied. So now the chance of getting 0, well, that's this one here. And 12 on 19 times 12 on 19 is 144 on 361. What about these two, where I get 1 red counter? Well, that's those two added together, which is 168 on 361. What's the chance of getting 2 reds? Well, that's 49 on 361. Remember, all these 3 things must add up to 1. Now to calculate the expected value, or the mean, zero times 144 on 361 plus 1 times 168 on 361 plus 2 times 49 on 361, which gives me 266 on 361, which is 14 on 19. So what's the expected number of reds? Well, it's not even 1. When you're picking these counters out, it's not even 1. You wouldn't expect to even get 1 red counter. And that sounds right because there are 12 white counters and only 7 red. So you'd expect not to get a whole red counter. Now, the probability without replacement, so a red and a red and a white and a red, and a white and a white. Well, the first probability stays the same. 7 on 19, 7 on 19, 12 on 19, 12 on 19. But when I'm choosing the second one and I'm going to multiply these, I'm not putting the first counter back. So now, a red and a red, there are 6 red counters and there are only 18. A red and a white, there are 12 white counters, but there are still only 18 counters. A white and a red, well, there are 12. Now a red, there are 7 reds, but only 18 counters. A white and a white, well, now there are 11 white and 18 counters. And you work out all those probabilities, and it's done in the work solutions. It's pretty easy. You do exactly the same thing and add them up. Number 6, okay, it's just another nice easy one. It says it's a uniform discrete probability. So if I do number 6 over here, so number 6, I'll do it down here, number 6, what have I got to get? I've got to get a 1, 2, 3 or 4, I'm pretty sure. 1, 2, 3 or 4, and they've all got the same chance. So my X is 1, 2, 3 and 4, and they've all got to have the same probability. So P of X, 1 on 4, 1 on 4, 1 on 4, 1 on 4. They've all got the same probability. So, and then draw up the probability distribution, find E of X again. So E of X equals 1 times 1 on 4 plus 2 times 1 on 4 plus 3 times 1 on 4 plus 4 times 1 on 4. Now, remember, you can just put it in your calculator and put that in your X column and put the probabilities in your F of X column. You'll get the same answer. I'm going to do this in my calculator in a minute so that you can see it's the same. So that's a quarter plus 2 quarters plus 3 quarters plus 4 quarters. And I do it like that so it makes it easier. That's 10 quarters, which is 2.5. So watch what happens when I put it in the calculator in the statistics mode. So go set up, put it in stat, go number 1. I got 1, 2, 3, 4. Go over here. It's so much quicker this way. And I go 1 divided by 4, 1 divided by 4. See how it's writing it as a decimal, 1 divided by 4 and 1 divided by 4. Press all clear. Go down here, shift, stat, get in number 4. I want the variable. I want the mean, even though it says sample, don't worry about it. Go bang, 2.5. All right, I'm going to leave you to do the others. If you have any questions, they're all pretty similar. You just got to write out the probability distribution table. They start talking about money in question 9, so you're playing a game. But have a look at the work solutions. They're pretty easy to follow. They do them all without using the calculator, but please make sure you know how to use the calculator. Good luck with that.